To solve using the simplex method, we need to set up a simplex tableau. And to do that, we first restate the problem by introducing slack variables. We introduce a slack variable to each constraint, that means to each linear inequality. And to do that, we add a slack variable to the left side of each inequality. So this first inequality becomes x1 plus x2 plus x3 plus the slack variable s1 is equal to 100. This second becomes x2 plus 5x3 plus the second slack variable s2 equals 90. And the third inequality becomes 2x1 plus 2x2 plus 3x3 plus the third slack variable s3 is equal to 150. So that's the first step, restating the problem by introducing slack variables. We don't need to do anything at this step with the first equation involving z, which is the objective function. Okay, so now we want to set up a matrix with a row for each of those three constraints that we have, and a column for each variable, and also a column for each slack variable. So that means we're going to have right now 3 rows and 6 columns in this matrix. So the columns will be x1, x2, x3, s1, s2, s3. This isn't part of the matrix, this is just labels for the outside. And then we'll also label rows, so C1 for constraint 1, which is this one, C2 for constraint 2, and C3 for constraint 3. So these are just labels for our matrix. Now let's fill in the coefficients of each equation. So in constraint 1, the coefficient of x1 is 1, x2 is 1, x3 is 1, s1 is 1. So that would be 1, 1, 1, 1. And there's no s2 or s3 in this first equation, so we'll put zeros in those spots. In constraint 2, no x1 appears in the equation, so we'll put a 0 in the matrix there. We'll put a 1 for x2, a 5 for x3, and then a 1 for s2, a 0 for s1, and a 0 for s3 since those don't appear in the equation. Constraint 3, we'll put a 2 for x1, a 2 for x2, and a 3 for x3. There's no s1, there's no s2, and the coefficient of s3 is 1. Okay, so that's step 2, setting up the matrix. And now we're going to involve the objective function, which is the one that has z in it. And we want to move all variables to the left in the objective function. So that would be subtracting each of these from both sides. That would give us the new equation, negative x1 minus x2 minus 4x3 plus z is equal to 0. So it's just rewriting that equation by moving everything to the left. So now we're going to add another column to our matrix, and we're going to label it z. And then we're also going to add another row for that objective function. I'll call it O, but I don't want it to look like a 0, so I'll do a cursive O for the objective function. So in the objective function, the coefficient of x1 is negative 1. Coefficient of x2 is negative 1. The coefficient of x3 is negative 4. And there are no s slack variables in the objective function, so we put zeros for those spots, and the coefficient of z is 1. Now also in the z column, since z doesn't appear in any of the constraint equations, we can put zeros for z in those equations. Okay, that's step 3. Step 4 is to augment this matrix with the numbers on the right side of each equation. So that means the number for constraint 1 is 100. For constraint 2 is 90. For constraint 3 is 150. and then the number on the right side in the objective function was 0. So this is the setup of the matrix. Now we'll just make it look like a matrix. We can keep the labels on the outside, but those aren't actually a part of the entries of the matrix. And this is what's known as the Simplex Tableau to use for the Simplex method. You'll notice we write it as an augmented matrix with the objective function at the bottom separated from the constraints, and also with the answer numbers augmented on the right and separated from the variables.